If all you know is how to make a simple API call to an LLM, you are already falling behind. In 2026, enterprise companies are no longer hiring prompt engineers, they are desperately looking for agentic AI engineers who can architect secure, hallucination free data systems. The hard truth is that the smartest language model on the planet is completely useless if your underlying data retrieval pipeline is garbage. In this video, you will learn three things. First, how vector embeddings actually work to retrieve meaning instead of just matching keywords. Second, the advanced retrieval pipeline, focusing on semantic chunking and re-ranking to find the exact needle in your document haystack. And third, the critical shift to agentic RAG, where we build reasoning loops that allow agents to think before they speak. Let's get started. Let us break down the first pillar of this architecture, vector embeddings and vector databases. Definition: computers do not understand words, they understand math. An embedding model converts your text, images, or code into high-dimensional numerical arrays. A vector database stores these numbers so the system can instantly find documents that are mathematically closest in meaning to a user's query. Analogy: think of this like searching for food on Zomato or Swiggy. If you type spicy chicken gravy into a standard keyword search, it only looks for those exact letters. It might miss Murg tikka masala because the spelling is different, but a vector search understands the concept. It knows that spicy chicken gravy and Murg tikka masala live in the same neighborhood of mathematical space. Even though the words are completely different, it retrieves by meaning, not by spelling. Visual cue: imagine a massive 3D galaxy where every star is a document. Similar topics cluster together. Your query is a spaceship flying to the nearest cluster of stars to grab the relevant data. Stop fine-tuning models to teach them facts. Give them a search engine instead. The second concept is the retrieval pipeline, specifically chunking and re-ranking. Definition: you cannot feed a 5,000-page enterprise document into a model efficiently. You must slice it into smaller pieces called chunks. Once the vector database finds the top 50 paragraphs that might match, a specialized model called a ranker grades them. It passes only the absolute best 5 paragraphs to the large language model to generate the final answer. Analogy: imagine you are solving a complex Jira ticket. You do not read the entire documentation library from cover to cover. That would take forever. Instead, you skim the index to find 5 relevant pages. You read those 5 pages very carefully to find the exact 3 lines of code you need to copy and paste. The vector search is the skim. The re-ranker is the careful reading. Visual cue: show a funnel. A wide stream of documents enters the top. A chunking filter breaks them up. A vector search lens picks the top 50. Our Reranker magnet pulls out the top 5 gold nuggets at the bottom. What it is not, this is not fine-tuning. Fine-tuning updates the model's brain permanently. Chunking and retrieval is just handing the model a relevant cheat sheet for one specific question. The third and most critical concept for 2026 is agentic RAG definition. This is a stateful architecture where an agent uses reasoning loops. It formulates queries, assesses retrieved data, and autonomously performs multi-hop searches if the initial data is insufficient. Analogy: basic RAG is like an intern who Googles an error code once, copies the first Stack Overflow link, and bursts it into Slack without thinking. Agentic RAG is like a senior staff engineer. They Google the error, read the documentation, realize the first solution is outdated, check the internal GitHub repository. At the end, only then give you the correct fix. It is a multi-step investigation, not a single guess. Visual cue: a flowchart showing a loop. Let us look at the file on the screen. Notice we are not just calling a chain. We are defining a state graph using LangGraph. The code initializes a state dictionary to hold our messages and the number of steps taken. The critical function here is it checks the retrieved context. If the agent decides the information is weak, it loops back to rewrite the search query instead of generating an answer immediately. This loop is what separates a toy prototype from an enterprise tool. The agent thinks before it speaks. Let us see this in action with a concrete example from the field. In early 2025, an enterprise deployed a basic RAG chatbot for their audit team. A user asked a simple question: which 5 vendors had the highest risk across the last 3 audits? The basic system failed miserably. It performed a vector search for vendor risk. It pulled the top 5 chunks containing those words, but it missed the timeline completely. It grabbed risk data from 2022 instead of the last 3 audits. The answer was confident, but wrong. In mid 2026, they upgraded to Agenting RA. Watch how the agent handled the same question. First, the agent planned its attack. It recognized it needed a list of vendors before it could check risks. Second, it retrieved the master vendor list. Third, it entered a loop. It went through the vector database to check the last 3 audits for each vendor individually. Finally, it calculated the risk scores based on that specific data and generated a flawless, verifiable report with citations. The difference was not the model. The difference was the architecture. The agent treated the question as a project to be managed. The most critical takeaway today is this: the intelligence of your AI application depends entirely on the strength of your retrieval architecture, not just the size of your LLM. You just saw how vector embeddings search by meaning instead of spelling. You just saw how chunking and re-ranking filter out noise to pass only the absolute best data forward. And you just saw why Agentic RAG uses reasoning loops to verify and correct its own searches before it ever speaks. Your next step is to stop building basic chains and start building stateful agents. Go refactor one of your existing RAG pipelines today using LangGraph to add a self-correction loop,